Hello friends, welcome back to Rising Mathematics. In this video, we are going to solve this question from book Contemporary Abstract Algebra by Gallian. Question is, let A belong to a group and A12 is identity. Express the inverse of each of the elements A, A6, A8 and A11 in the form AK for some positive integer k. Now note that if G is a group with binary operation, say star, then for any element A in group G and for some positive integer k, AK is A star and so on A star k times. Now we have given that A12 is identity, that is A star and so on A star 12 times gives us identity. Then we need to find inverses of these elements. Now, in order to find inverses of the given elements, firstly we will recall a theorem which we are going to use to find the inverses of the given elements. So, theorem is, let G is a group with binary operation star and let G is some element of group G and let Mn are some integers, then Gm plus n will be Gm star Gn and Gmn will be Gmn. So we will start our solution. Now our claim is to find inverses of elements A, A6, A8 and A11 and we have given that A12 is identity element of group G. Now note that from the above theorem we can write A12 as A1 star A11. Here we have assumed that star is our binary operation. So A12 can be written as A1 star A11. Then we have A12 equals to identity will imply we will replace this A12 by this. So A1 star A11 will be identity. Now as it is given that all these are elements of the group and in group inverse element is unique. So from this expression we get inverse of A1, that is inverse of A will be A11. So inverse of A1, that is A will be A11. Next we can write A12 as A6 star A6 using above theorem. Then A12 equals to identity implies A6 star A6 is equal to identity. Again using uniqueness of inverses in a group, we have inverse of A6 will be A6, that is A6 is self inverse element. Next we can write A12 as A8 star A4. Then A12 equals to identity implies A8 star A4 is equal to identity. So using uniqueness of inverses we get inverse of A8 will be A4. Now our last element is A11, that is we need to find inverse of A11. Again we can write A12 as A11 star A1 using above theorem. So A12 equals to identity implies A11 star A1 equals to identity and thus inverse of A11 will be A1, that is A. And so we have found that for given condition A12 equals to identity, inverse of A is A11, inverse of A6 is A6, inverse of A8 is A4 and inverse of A11 is A, and this completes our solution.